So for the first question here, if you have a voltage across the 5 farad capacitor, this is the voltage. Find the current. We need to find the current and power. Okay, we need to find the current and power. So all what you have to do here is to apply the equation for the capacitor. Let me do it here. So we have a voltage, we have a capacitor. So here we have capacitor. That's 5 farad. And we have the voltage across this capacitor is 2T. This is given here, 2T times e to the power of negative 3T. This is the voltage. And you need to find the current here, I. You need to find this I. According to the relations of the voltage and current, I equal C, the I for the capacitor, IC equals C dVc by dt, dVc by dt, which is 4V dot. Then C equal 5. C is just 5. Then all what you have to do is just differentiate the voltage. Differentiate this one here. When you differentiate this is actually multiplication. Then you can take 2 outside. Or you can leave it. You can leave it. You can leave this 2 outside here. Okay. And then differentiate this one, this part. It is 2 function, t times e to the power of negative 3t. When you differentiate it, you can differentiate the first one, multiplied by the second one, and then differentiate the second one and multiplied by the first one. When you differentiate, t is 1, so it will be e to the power of negative 3t. Okay, plus. When you differentiate, e to the power of negative 3t will be negative 3 e to the power of negative 3t. Okay, time what? Time t. Time t. And then you close this one and this one. Okay, so this is how we do it. So this is the first column, whereas the second column is this one here. And we close it here. Okay, and then you can just add these two. E to the power of negative 3t minus 3t e to the power of negative 3t, and then you can multiply, you can add them, and this will give you the current. The power equal V times I. V times I. That's it. You can just multiply them. You have the voltage. This is the voltage. And the current is here. This is the current. This is all for the current. Okay, that's it. So this will be the solution of the first one. The solution of the first one. Let us do the second one. Second one. Select all. Or just let us move to the next one. Second one. See here that we have a current 6 sine 40 flows through a 2 farad capacitor. We need to find the voltage. The initial voltage is 1, so the capacitor was initially 1. So here, what we need to do here, then we have this capacitor here, and we know the current. This current is 6 sine t. 6 sine 40. Sine 40. And we need to find this voltage. V. Okay. And the capacitance is 2 farad. The capacitance is 2 farad. Then according to the relation which I gave you before, V equal 1 over C integration from 0 to t I dt. The previous lecture, I said this is VC and IC. Then you know now that this is the current in the capacitor and the voltage across the capacitor. But what is new here is that you have to add initial voltage. When you do the integration, you have to add the initial voltage. If it is not given, then you just neglect it. Then you can add it plus V0. Okay. Then this V0 equal is given here. V0 is 1. So you can just add 1 here. This is 1. Okay, and C equal 2. C equal 2. So it will be 1 over 2 integration of what? I equal what? I equal 6 sine 40. So you need to integrate this part here. Then how we do that? Again, 1 over C is 1 over 2. So this 1 over 2. We're done with this. And this 6 you can get you can move it outside. 6. And then the integration of sine 40 is negative cosine. Negative cosine 4t divided by 4. The integration of sine is negative cosine. Since you have 40 here, you have to divide by 40 by 4. And this is from 0 to t. And then you add 1, this one here. Then after that, you can just simplify everything. This 6 and 2 will be 3. Right? And then 3 divided by 4. Then you can say 3 divided by 4. Okay. And then substitute. When t equal t, just t. It is negative cosine 40. So this is the first part. When t equal t, just t. And then when t equals 0, it will be 1. So it will be minus. This will be minus 1. Minus 1. Okay. Cosine 4t when t equals 0 is 1. And you have a negative, so it's just 1. It will be negative 1. Plus 1. You add 1 here. This is 1. Don't forget it. So this is equal 3 over 4. Okay. Multiplied by what? Negative cosine 4t. And here negative will be plus 1. This negative will be plus 1. So you can rearrange it. You can say 1 minus cosine 4t. And then you add 1 again. This is the same one. And let us simplify it more if you want. 3 over 4 is 3 over 4. Okay. So 3 over 4 times 1 is 3 over 4. You can add this one to it. 3 over 4 plus 1 is 7 over 4. Then you can remove this one and you can add it. Will be 7 over 4. 3 over 4 plus 1 is 7 over 4. So it will be 7 over 4 minus 3 over 4 cosine 40. Then this will be the answer, like the ones that we have here. Okay, so these are the detailed solution. This is a detailed solution for this problem. Let us see the next one. Okay, put space here. Next one, see what here? That we have voltage. This is a voltage. And we need to find what here applied on a capacitor. The capacitor is 30 microfarad. 30 microfarad. 30 micro is 10 to the power of negative 6. We need to draw the current waveform. So first, we need to remember what is the relation of between voltage and current in the capacitor. We need to find the currents in I equal what? C dVc by dt. C dV by dt. C dV by dt. Then C equal 30 micro. So it's 30 microfarad, 10 to the power of negative 6. Okay. Time dV by dt. That's it. dV by dt. Then actually we can say that this is this ampere, for example. Of course, this is a current. Then you can say, okay, this one is 30. You can just say 30 time dV by dt. Okay, 30 dV by dt microampere. Microampere. Because you have negative 10 to the power of negative 6. So this 10 to the power of negative 6 is micro. Then now we are ready to look at this curve. The question here is how to find this dV by dt. dV by dt. dV by dt for a line is the slope. The slope. So if we have any slope like this, any line like this, find the slope, which is tan this angle here. Find the slope. Tan this angle. This is the slope. So you find this x, for example, this y, and divided by this x. So this is a derivative. Derivative is y over x. Y over x. Then, in this case, we can find the derivative of this. But how can we do that? We just try to, we have to draw it like this, and we divide it into divisions 2, 4, 6, 8, 10, 12, and so on. 2, 4, 6, 8, 10, 12. And then after that we can plot. So this is a current I here in microampere. Okay, and this is time t. First, between 0 and 2. Between 0 and 2. Between 0 and 2. The slope of this line is what? Is 10. So y is 10, and the x is 2. 10 divided by 2 is 5. That's it. So you just say 5. Okay, it is 5. So this is 5. So from 0 to 2, it is just 5. The current is 5. 5 microfarad. 5 times what? Times 30. So this is a derivative. You multiply it by 30 will be 150. Okay. So again, this one is the dV by dt equal 5. dV by dt is the slope, which is 5. 5 times 30, because you have 30 here. You have this 30. So it will be 150. 150 microfarad. The next, between 2 and 4, it is just constant. And we know that the derivative of the constant is 0. And you know also that the slope of this line here is 0 also. Because it is the angle is 0. Tan 0, 0. Or this is just constant, and the differentiation of constant is 0. Then this will be this part here. From 2 to 4. And then after that, from 4 to 8. From 4 to 8. So what is the slope of this line? You have to find first the y. The y here will be what? Will be negative 10 minus 10. Negative 10 minus 10, which is negative 20, divided by what? By the difference in x. The difference in x is 8 minus 4, which is 4. So it will be negative 20 divided by 4. Negative 20 divided by 4 is negative 5. So the derivative of this line is negative 5. Negative 5. Negative 5 times 30 will be negative 150. So it will be like this. And this one is negative 150. Okay. And then the last one. So this is supposed to be continue like this, because it is from 4, 6, 8. Okay. And then the last one is from, no, we still have this one from 8 to 10 is just 0, because derivative is 0. And then the last one is from this point to this point. The slope here is, the difference here is 10. 0 minus 10 is 10. And this is divided by 2. 10 divided by 2 is 5. That will be 150 again. So the curve for the current will look like this. We just need to connect it. Like this. That's it. So this will be the current. This will be the current in microampere. It is not in milli, I believe it is in microfarad. Microampere. 30 times 100, yes. Supposed to be in microampere, not milliampere. This is not right. If I'm writing this. Yes.